First of all, I would like to talk about the task which I gave you people. So in the last class, we were going through it. I guess I got we have to. Uh, Actually, I was just explaining it in the class. I'm sorry, but I have to sort it out. I have to also. I thought of adding, but my schedule is little crazy. I'm sorry. I'll do it in 1 or 2 days. Meanwhile, you can just check your assignments in the records itself. You'll find them. Hope if you have gone through the records, then you can see that. Okay. And you can add you can send me your assignments which you people have done through the mail. So if you people have completed it, you know, I got only one reply. uh, is Monasa did that assignment, but others I'm yet to get the response from you people. Yes, please try to do the tasks. Okay, fine. So let's start now. So in the last class we were talking about method overriding. Method overriding. Yes. Method overriding. This is what we did in the last class. Now you know what is method overriding, and we got certain rules which you need to follow while overriding the methods as we have discussed. Yes. Um, Today, I have a question based on that method overriding concept, and it will clarify a few more things to you people. Let's go through that question once. Okay. Just a second. Sorry. So I'm going to show you people a question now based on that method overloading or overriding concept. I'm sorry. Okay. So just check this question, all of you. Yes. Just go through this question. Give me the answer. What will be the answer for this question? Okay. Option B. Okay. Again, wait. A and D. A. Okay. So you got actually two answers. Choose two. Have you noticed it? Choose to. Okay. Yes. So is anyone else left over? Okay. Fine. Okay. Good. Most of you people have responded. Fine. So what is the question? Let me explain it now. Okay. Just check this once. So you got a class called as A, and in the class A, we got a method whose name is method one, and it takes two integer parameters. It takes two integer parameters. Yes. So that is the method which you got in that A class. It's protected. The return type is integer. Okay, fine. You see, what is the question here? It says which two are valid in a class that extends A. So the class which extends A, that means the subclass of A. In that subclass, which two methods are valid? Okay. So the first method, what is it? Public int method one, int comma int A comma int B. So this method, can we add it to the subclass? Is it valid in the subclass? So what do you people think? This method, is it valid in the subclass? So how will you check that? First of all, okay, if we define this method in the subclass, we need to check whether it is overriding or not. So there are certain rules, right, for overriding. The first rule is the method signature should be same. So you see the question also, it doesn't say whether it is overriding or not. The question is whether the method, if we define that method in the subclass, is it legal or not? It is valid or not? That is the question, right? So as of now, you see the method signature here, is it same or different? The method signature is same, right? That means it is overriding. If we define this method in the subclass, it would be overriding itself. If we define the method in the subclass, it would be overriding. Yes. So if it is overriding, then you got two rules, right? If it is overriding, you got couple of rules. What are they? Number one, the return type rule. First access modifier rule. So the subclass, it can use the same access modifier which is used by the superclass method, right? And the subclass can also use an access modifier which is less restricted than superclass method access modifier. So in this case, you see the subclass method uses public, so which is less restricted than protected. So subclass can definitely use this access modifier. So this is perfectly valid. And the other rule is the return type rule. Either the subclass can use the same return type, subclass method can use the same return type, or use a return type which is a subtype of superclass method return type. The return type should be subtype of superclass method return type here. So as of now, the return type is same. So this is perfectly valid method in the subclass. Yes. Okay, just a minute. So all of you who have joined late, so who joined just now, see, I'm just showing you people an exercise, a question. Uh, you know, this question you have to check whether in a subclass that methods, can we add those methods in the subclass or not? Subclass of A can have what methods here? What are the legal methods that you need to check? Yes. So that is what I'm explaining. Now see the second option B. So can we define that method in the subclass? That method B, can we define it in the subclass? Yes. Can we define this method in the subclass? If we define this method, so will it be overriding? First of all, you have to check the method signature. So the method signature is same. That means if we define this method in the subclass, that means this method will be overriding the superclass method. But there are certain rules, right, for overriding. First of all, the access modifier rule. So the subclass can use the same access modifier or a less restricted access modifier. So as of now, private, is it less restricted or more restricted? It is more restricted. So can we use this access modifier while overriding the superclass method? Subclass, will it be able to use this access modifier? I can say it is not possible. Subclass cannot do that, right? So subclass will not be able to do that. Yes. So the access modifier is the problem here. You cannot add this method in the subclass which extends A. Okay. Next to C. What about C? Okay. Same, private is more restricted, huh? But is it overriding actually? If we add this method in the subclass, can I say that it is overriding the superclass method? Can I say that it is overriding the superclass method? No, right? Because in case of overriding the first rule, what is it? So the method signature has to be same. The method signature is not same here. The superclass method is int comma int. Now this method is int comma long. So that method signature is different. The parameter types list is different. If method signature is same, the parameter types list has to be same. So this is not valid. Okay. So fine, it is not overriding. That means, can I say this is overloading? Can I say this is overloading? Can I say this is overloading? Because same method name, different parameter types list, right? So I can say yes, of course. Yes, of course. Now you see, in the subclass already the superclass method will be inherited. So in the subclass I can say that you got this method 1 which takes 2 integers. Now in the subclass you are adding another method which takes 1 integer and 1 long value. That means in the subclass now you have 2 methods with the same name but different parameter types list. So of course this is overloading itself, right? Method overloading. No, you might be thinking about this access modified is private. But did I ever talk about access modifiers return type in method overloading? Are they considered in method overloading? Yes. Actually, in method overloading, the return type is not considered. The access modifier is also not considered. Yes. Okay. So return type is not considered. Even access modifier is also not considered. So that means, can I say that this is a valid method in the subclass? Can I say that this is a valid method in the subclass? Yes, of course. This is a valid method. Okay. This is a valid method here. Okay, good. So C is the right option. What about D? What is the issue with D? Is there any issue with D? Or is it also a valid option? What do people think? Is D also a valid option? Or is there any issue with it? D. Not valid, okay. Nope, it's short. Yes. You know what? Sometimes people may think that short, it is within the range of integer. So short, they say that it is a subtype of integer, but that is totally false. You know, this subtype means a subclass. This inheritance concept is only valid for the classes, not for the primitive data types. Inheritance concept is not valid for primitive data types. You got the point, all of you? Inheritance concept is not valid for primitive data types. So one type is not a subtype, one primitive data type is not a subtype of another primitive data type. Okay, yes. So the problem is short here. The return type is a problem. Yes. Next, what about the last option here? So what is the issue with the last option? Yeah, you see, in the superclass, the method is non-static. In the subclass, you see, if you're overriding it, you cannot make it static. Okay, you cannot make it static. And moreover, the concept of overriding, it's only for non-static methods, not for static methods. Okay, so overriding concept is only for non-static methods, not for static methods. So that is the wrong option here. Okay, so the right answer is A and C. Hope everyone got it right. So now one point what you can understand here is that the subclasses can also overload the superclass method. A subclass can overload the superclass method here. That is perfectly valid. Okay. Yes. Fine. Next, what else we got? Fine. Let's move on. In the last class, if you people remember, so I was talking about the object references. You see, as I told you people, A subclass object reference can be stored into a superclass reference variable. That is what you're looking at here. A subclass object reference can be stored into a superclass reference variable, right? Yes. So here this is only possible because of inheritance. Yes, because there is a parent-child relationship. Now there are few things which you need to know here regarding this reference type. You know, initially when the compiler compiles this code, especially when it finds this, when it comes across this method call, you see, when the compiler comes across this method call, you know what it does? So first of all, it will check whether this withdraw method is in that savings account class or not. It will check whether that withdraw method is in the savings account class or not. So why it will check whether the withdraw method is in the savings account class or not? Because you know, during the compile time, objects, they are not created. During the compile time, objects are not created. When exactly the objects are created? When exactly the objects are created? The objects are created during the runtime, not during the compile time. So compiler will never check what object reference is stored here in this reference variable. It always goes with that variable type. So the variable is what type? Savings account class type. So simply it will check whether that withdraw method is defined in the superclass, sorry, in that savings account class or not. If it finds it, then simply it considers that it is a valid method call. But you know, it won't bind this method call to that method definition. It will not bind the method call to the method definition. Binding of method call to the method definition, it takes place at runtime. Okay, in case of method overriding concept, you will find that the binding, it takes place at runtime, method binding. So earlier, when I was talking about method overloading concept, so we have discussed about binding. Sorry, yeah, binding, we have discussed about it, right? So what is method binding? As I told you people, associating a method call to the method definition is called as method binding. Associating a method call to the method definition is called as method binding. So where in case of the overloading concept, it happens during the compile time, you know, because you know, in case of method overloading, you have all the distinct methods. All the methods which are overloaded are distinct methods. You know, they're not same like method overriding concept. They're all distinct methods. Compiler will not have any issues identifying that method associated to this method call. But you see, when it comes to method overriding, all of you please listen to me carefully. In case of method overriding, so what happens is you'll find that the binding is deferred to runtime. Okay, binding is done during the runtime. Binding means associating the method call to the method definition. Yeah, it takes place at runtime. Here, you know, why it is deferred to runtime? Why not compile time? Now, this point you need to understand. What do you people think in case of method overriding? Why the method binding is deferred to runtime? Why not at compile time? Okay, I got some answer. Let me see. Okay, you want me to repeat the question, Neil? Okay, you see, I'm saying that in case of method overloading, already I've explained it. In method overloading, that method binding or method resolution takes place at compile time. During the compile time itself, it takes place. But when it comes to method binding in case of method overriding, in case of method overriding, that method binding or method resolution is deferred to runtime. Why so? Why it is deferred to runtime? Why method binding is deferred to runtime? Okay, I got one answer. So different classes can work in tandem. They're already compiled as they can work together. No, you know, I'll tell you people why the method binding takes place at runtime in case of method overriding. I'll tell you people. So there are two things which you need to understand. The compiler, it cannot associate this method call to the method definition because the compiler, it knows that there is more than one method with the same signature in two different classes. In the superclass and subclass, in both the classes we have that method. That means both the methods will qualify here for the method call. They both will qualify the method call. Because you see, we're using superclass reference variable, right? A superclass reference variable can take subclass object reference as well as it can take its own object reference. For example, in this case, saying you got account reference variable, it is savings account type. So savings account reference variable can take savings account object reference, and it can also take subclass object references. Okay, at this point here, the compiler will not be able to identify or understand what object reference will be stored in that reference variable, because object is not yet created. During the compile time, objects are not created. So compiler will never bother about the object reference because it cannot understand what object reference is stored in that reference variable. It will only go with the object type, reference variable type. So it understands that it is a savings account, super type. So that reference variable can take subclass object reference as well as superclass object reference. That means same class object reference. So now that withdraw method call here, which you got, for this method call, the subclass method is eligible and superclass method is also eligible for that method call. Any one of the method can be, both are eligible for that method call. Both have got the same signature. So that's the reason why for the compiler this is a kind of ambiguity situation. So it doesn't know. Now here there are more than one method with the same method signature and both the methods qualify for that method call. Okay, so what it does, it will simply defer it to the runtime. Why to the runtime? Because at runtime what happens, how this method resolution takes place. Yes, at runtime objects are created, and you see, based on the object reference which is stored in that reference variable, the method call will be associated to the method definition here. You see, in our example, which class object reference is stored in that reference variable? You know, subclass object reference is stored in that reference variable. So subclass method will be invoked. That's it. Based on the object reference, now the method binding takes place. Okay. So which method to invoke for that method call? Which method will be bound to that method call? It is decided based on the object reference. So if it is subclass object reference, subclass method will be called. So if it is that savings account type reference, object reference, then savings account method will be invoked. That's it. Is it clear for you people? So hope everyone got it. Because this issue will not have it for method overloading. Why so? Because in case of method overloading, every method is distinct. They are not different. They are not same. You see, now we got these two methods. We can say that these two methods are distinct, though method name is same, but still parameter types list will be of course different. It won't be same. So the compiler in that case, there won't be any issue for the compiler to understand which method to call based on that based on the arguments which you're passing to that method. It can easily make a decision in that case, in case of method overloading. But only in case of method overriding, the problem arises because there are two issues here. You see, the method name signature is same, so that's the first confusion. And during the now further, what happens is the compiler will not be able to check what object reference is stored in this reference variable. If it can do that, then it can at least associate based on that object reference. It can associate it, but objects are not created at compile time. Objects are created at runtime. So that's the reason why you see the method binding is deferred to runtime. So that's the reason why this method binding, okay, which takes place at runtime, it is called as late binding. Late binding. Okay, it is called as late binding, or it is also called as dynamic binding. Dynamic binding, because during the execution it takes place, right? During the execution of the code it takes place. So that's the reason why we call it as dynamic binding. Okay, or late binding. Late means only after the application starts execution the binding takes place based on that method call, based on that object reference which is stored in that reference variable. So this is late binding. Dynamic means during the execution it happens. Okay, when the application is executing at that time it happens. So that's the reason why we call it as dynamic binding here. So any questions in this regard, please let me know. Okay. Now one more important point here. So you see, when we are storing a subclass object reference in a superclass reference variable, so we cannot call the methods which are only defined in the subclass. You cannot use this reference to call the methods which are only defined in the subclass. For suppose, um, let me do this. In the subclass, I will add a method with the name getDetails, let's say. And we'll try to print this details. Account number, save balance. Okay, let's say I would like to print these details. Now, where is this method? Only in the subclass, not in the superclass. Now, you cannot call this method using this reference now. You see, in this reference variable account now you got subclass object reference, but still you cannot call that method get details using that object reference. Why so? I can say you people know the answer. The only thing is you have to think about it. I can say you people are familiar with that answer. You see, I can't do that now. I can't do this. Account dot get details. So it is only defined in the subclass, right? So you cannot call this method. Get details is undefined for the type savings account. So why we cannot do this? I can say you know the answer. No, you know the reason I already explained it. I can say because yes, you know during the compile time, as I told you people, the compiler will only go with the reference variable type. The reference variable type is savings account. So simply it will check whether this method is defined in the savings account class or not. Simply it will check whether this method is defined in the savings account class or not. But that method is not defined in the savings account. Okay. So though you know that in that reference variable, the junior savings account object reference will be stored, but your compiler will not check it because during the compile time objects are not created. So compiler is least bothered about it now. Okay, compiler is least bothered. So it will only understand that you're trying to use that reference variable to call that. That means we are trying to call a method called as get details, which is in the savings account class. Okay, yes, yep. So that's the error. So whenever the subclass object reference is stored in a superclass variable, you'll find that we cannot call the subclass methods or the methods which are only defined in the subclass. We cannot invoke them. Yes. Yes, fine. Now one last thing which I would like to show you people here is, now you see that reference variable is going to take or it is going to store that say junior savings account object reference, right? Now what I want to do is here, I would like to store that junior savings account object reference into junior savings account reference variable itself. You see that account variable, it holds junior savings account object reference. I'm trying to assign that object reference which is in this account variable to the reference variable of type junior savings account. That means junior savings account object reference, we are storing it back into junior savings account reference variable here. That is what we are trying to do. Yes. But you see, when I'm trying to do this here, I got an error. Can you people tell me what is this error here? Why we are getting an error here? No, at first place, why we are getting an error? You see, in that account reference
Type
variable,
mismatch.
yeah, tell me. Yes, Sadbir, go on.
It's the this account before like it's a saving account. It's a basically a type mismatch. So we need to cast the account variable into junior saving account first in order to assign to junior saving account reference.
Yeah, but you know that in this account reference variable, we got junior savings account object reference, right? We're trying
Yeah.
to just assign that, so why it won't take it?
But the reference is a saving account, right?
Okay, I'll tell you people. Because again, the same issue. The compiler during the compile time, it will only check this reference variable types, not the object references. So the compiler now what it does, it will only check whether this variable types are yes, they are matching or not. The compiler what it is trying to understand is that here we are trying to assign a superclass object reference to a subclass reference variable. It understands that according to the compiler what it assumes that it assumes that we are trying to assign the superclass object reference to subclass reference variable. You know, a superclass object reference we cannot store it in a subclass reference variable. It is not possible. Okay, that is not possible. Subclass object reference can be stored in a superclass reference variable, but vice versa is not possible. Okay, vice versa is not possible. Yes. So because the compiler will not check the object references, right? You see, compiler cannot understand that in this reference variable we got junior savings account object reference because the objects are not created at compile time. That is the problem. Yeah. Okay. So now what to do? We need to explicitly ask the compiler to convert that savings account type to junior savings account type using casting operator. So already we have used casting operator, right? Yes. So already we have used casting operator. Now using the casting
Mahesh, can you
operator, you can explicitly specify to what type you want this savings account to convert. Yes. Yes, Sadbir. Tell me.
so can you repeat the the concept of how the compiler check during the compile time
Yeah,
in
the
this
compiler,
case?
what it does is it will only go with that reference variable types, not the object reference which is stored. Actually, if the compiler considers object reference, then it should allow it, right? Because in the reference variable, account reference variable, you got junior savings account object reference. So what will be the problem to assign that as a junior savings account object reference to junior savings account reference variable? There should not be any problem, right? But compiler will not consider that object references because at compile time objects are not created. So when the objects are created during the runtime, so you see compiler will only go with reference variable types. Now what it understands is when you use this account variable, it assumes that okay, you're trying to store a superclass object reference to a subclass reference variable, which is not possible. A superclass reference object reference cannot be stored in a subclass reference variable. Okay, so the compiler is that is what the compiler assumes here. It assumes that you're trying to store a subclass object reference in a superclass reference variable. Sorry, superclass object reference in a subclass reference variable. But the fact is that in that reference variable account, you got subclass object reference itself. You see, that's the reason why we have to explicitly use this casting operator and explicitly mention to the compiler that that is junior savings account type. So please convert that savings account to junior savings account type. So it should be done. Okay. Yes. So we are asking, or we are forcing the compiler to anyhow convert that savings account type to junior savings account type. In our case, yes, it is downcasting. So it should be done it, because the reference is of course junior savings account type object reference itself. So there should not be any problems. Yeah, you got it, all of you? Yes. Still any questions? Okay, good. So please remember these points. Now let's move on to the next topic, that is abstract method and abstract class and class as well. So what is an abstract method? What is an abstract method? Yes, anyone got any idea about an abstract method? Yes. One that isn't defined thoroughly. Yes, that's right. You can say that. The method which is not completely defined. No bot. Yes, no body, no method definition. Yes. I guess I got one more answer here. Uh, that can be modified and overridden somewhere else. Okay. Yes. You know, abstract method means a method without a body or a definition. I can say something like this. Normally, for a method, you'll have a body. That angular brackets, they specify that method body. But you see, in place of body, I'll use semicolon. Okay, so you see, we can define such methods in a class. It is possible, totally perfect. You see, for suppose you got this order class, we got a method body. I'll delete this method body. Instead, I'll just replace it with a semicolon. So now this method is an abstract method, I can say, a method without a body or definition. So you know, whenever we define a method without a body in a class, it is mandatory that you declare it as abstract. Okay, so if you define an abstract method, it is mandatory that you declare it as abstract. Okay, it is mandatory that you declare it as abstract. And you know what? In a class, if you got an abstract method, then the class also should be declared as abstract. Abstract methods can be only defined in the abstract class. So the class also should be declared as abstract. So it is mandatory. So if you define an abstract method in a class, so class has to be declared as abstract. And you see, if you define a method without a body or definition, that means an abstract method. In that case also, you have to declare the method as abstract here. You have to declare the method as abstract. Yes. Okay. So this is abstract method, an abstract class. But now the question is here, why do we need abstract methods in abstract class? Why do we use this concept of abstract methods? What do people think? Yes. So why do we use this concept of abstract methods and abstract classes? Okay. So let me give you people an example for this. Okay. So I'll give you people an example. Yeah. Uh, Before that, just a minute, please. Just a minute. Yeah, sorry. Can you people hear me? Okay, fine. So let's see the concept of abstract class. You know, for this example, okay, to demonstrate the concept here, for this concept, I'm going to use the exercise, that example which I gave you people in the last task, in the last class. So I gave you people a task in the last class, right? I gave you people a task in the last class. So what is that assignment? I've asked you people to define the classes here to represent permanent employees and contract employees. Let's say you got two different types of employees. So they are objects, of course. Now I want you people to define, I wanted you people to define the Java classes to represent these two different types of employees here. So one person submitted the task, others and waiting for you people. Fine. So now I'm going to do this here in that class. You can just cross check your task, which you, if you people have completed it. Yes. Sorry. You can just cross check your task. So now if you are supposed to define the Java classes here, so then what would you do? First thing, what you're supposed to do here. So how will you start? Okay, got some response. Permanent employees is subclass. Okay. Subclass of which class? Subclass of which class? Okay. So let's see how to do this. How do you start here? So if you are supposed to define the classes here, yes. Then how will you start? What is the first thing you have to do here? Yes. Okay. So before defining the employee class, first of all, okay, before defining the class, first of all, you have to do one more thing, right? What is it? identify the properties and behaviors, right? So now what will be the properties and behaviors that you need to understand? So for every employee will have ID, you'll have a name, you'll have a designation, you'll have a phone number, email, right? So this is same for both contract and permanent employee. Let's say for contract employee, maybe contract period in years, let's say. So how many years the contract is given? Let's say that details you got it here. Okay, fine. Next, for the permanent employee, you may have appointment date. So which is important, right? For the permanent date employee, appointment date is important. Yes. And what else will be common here? I can say calculate salary. Let's say the functionality here, that behavior. So that is calculating salary, let's say. Just assume this. That is a common thing again between these two types of employees, calculating the salary. This is common again for both the employees. Okay. Now, let's, if you keenly observe this fields and the methods which you got here in these two classes, yes, you'll find that you got some common fields and methods between these two classes, right? Yes, as you people said, we can make use of inheritance here. Yes. Now we can define a class called as employee, and that common variables of fields and methods here, we can define them in the employee class, and you can make it a superclass for contract and permanent employee. That is what we can do here. Okay. Yes. So let's start. First of all, I'm going to define a class here called as employee. Employee has got an ID, it's got a name, it's got designation, and the phone and email. Fine. And we got that behavior. So calculate salary. So the functionality. This is the action which we can perform on the employees. Yes. Now we'll implement this method later on. Okay. So now we have to define the class, each class for each type of employee. We have to define a class for each type of employee here. For contract employee, one class. I'll make it extends employee. Okay. So this is a super class now. And then in this class here, we'll add one additional field which is specific to this class itself or this type of employee itself. That is a contract in years, let's say. That's it. Next, we'll define a permanent employee class. Okay, and I'll make it extends employee class. And here, set date. I'll I'll take it as string as of now. Later on, I'll discuss about date. Uh, Date of appointment. Let's say. Fine. So this way here we'll be defining those classes here. Okay. Yes. Okay. Now so far what we did, hope this is clear. Now both the classes will inherit the members of that employee class, that variables and methods defined in the employee class. Now they are inherited here, right? Yes. Okay. Now let's go back to the employee class here, and we need to implement this method, calculate salary. We need to implement the calculate salary method. Now here there is an important thing which we need to consider while calculating the salary for the employees. You see, the rules to calculate the salary for the contract employee will be different from the rules to calculate the salary for the permanent employees, right? So the rules are going to be different here. You know that. So no, but we need to implement that functionality here, right? To calculate the salary for the employees. Of course, the functionality is going to be different. Now, can we define the functionality here in the superclass, in this class employee class, such a way that it is appropriate for both the subclasses? Can we define that functionality or implement that functionality such a way that the functionality here is appropriate for both the subclasses? Can we do that? No? Why no? Because yes, you see both the classes will inherit this method, right? Both the classes will inherit this method. The functionalities are different. Now within the same method, it is not recommended that we implement the same functional, two different functionalities. Within the same method, it is not appropriate to implement two different functionalities. It is not recommended. So hope you people understood the issue here, right? Yes. So what to do then? In this situation, what we are doing, what we are supposed to do. Now it is difficult to implement that functionality in the superclass, in the employee class, such a way that it is appropriate for both the subclasses, right? Yes. So what to do here? This is where we use the concept of abstract methods. As of now, you see, implementing that method in the superclass will be difficult. Implementing that method here in the superclass will be difficult, right? So that's the reason why I'm not going to implement that method here, because we can't justify both the classes at the same time. So it is not possible. So that's the reason why I will declare, I will remove this method body, and instead I'll declare this method itself as abstract. So we are not implementing it here because it would be difficult for us to do that. Yes. Okay. Now I've declared this method as abstract. I've removed that method body. And as I told you people, so if we declare this method as abstract, we declare this method as abstract, then the class also has to be declared as abstract, because abstract methods, we can only define them in the abstract class. Declare the class as also abstract here. Yes. That's it. So now you see this method is not implemented here. Then where we are supposed to implement this method? In the subclass. So each subclass and both the subclasses will inherit this method, right? And they will be implementing this method. They will be implementing this method here. Yes. Now contract employee and the permanent employee, they both will inherit this method. They will implement this method according to their own requirement. See, when I say implementing this method, again it is overriding itself. This is the concept of overriding, I can say. I can say that it is overriding concept itself. Yes. Yeah. So you see in the contract employee class, I'll implement that method this way. Implementing means defining the method with the same signature, but additionally we'll add a method definition of body here. Yes. Fine. So now the functionality I'm not writing that here. Just let's say this method has got that functionality now to calculate the salary for contract employee. That's it. Okay. Now you see this class now you can implement that functionality to calculate the salary according to the contract employee rules. According to the contract employee rules, whatever they are, the functionality can be implemented. Now the same thing can be done in the other class also. So this is permanent employee. Yes. Okay. So now both the classes will implement that abstract method. They'll override that abstract method and they will provide that functionality. Yes, according to their requirement. See, this way we can make use of the abstract methods concept. So now what this superclass is doing here, through the abstract method, it will simply delegate the task of implementing the method to the subclass, I can say. You know, the subclass, if it inherits an abstract method from the superclass, it has to implement that abstract method. Now that is a rule. The subclass, if it inherits an abstract method from the superclass, it has to implement it. It has to override it. So it should provide that method definition. So that means, in other words, I can say that by defining the abstract method in the superclass, we are delegating the task of implementing that method to the subclass, because subclasses will be inheriting the superclass methods, right? Now they have to implement it. Yes. So this is one of the applications of abstract methods and an abstract class. So is it clear for you people what we did now? Any questions in this regard? Okay, any questions? No? So I have a question for you people. So my question is, you see, here in the superclass, we are not implementing this method, right? In the superclass, we are not implementing this method. Which method? The calculate salary method. So if we are not implementing this method in the superclass, you see, do we need to really define this method in the superclass? Can't we directly define that method in the subclasses itself instead of defining that method in the superclass, making it abstract? You know, why to do all those things? Can't we declare that, or can't we directly define that method in the subclasses itself? Can't we define that method directly in the subclass itself? So I hope you got my question right. Can't we directly define that method in the subclasses itself? Why to define it in the superclass? Okay, so now there is a question, the method, should it be protected or private? So I'll talk about it definitely. Okay, yes, we'll see that. But before that, so what do people think? Why we have to define this method in the superclass when we are not implementing it in the superclass, right? We are not implementing it here in the superclass. Why to define it here? Okay, don't worry about the answer. So first of all, is my question clear for you people? It is important to understand the question also. So is my question clear? Can I have yes or no? Okay, fine. So there are two reasons for this. Why we define the method in the superclass even though we are not implementing it in the superclass. For that I can say we got two reasons. So the first reason is, you know, by defining this method in the superclass, okay, by defining this method in the superclass, so we are making sure that each subclass definitely it implements this method. Every subclass implements this method. You're making sure that every subclass implements this method. How? You see, because if we define this abstract method here in the superclass, then what happens? Now, all the subclasses will inherit this abstract method, right? They will inherit this abstract method. And now, it is mandatory for each subclass to implement this method as well. It is mandatory for each subclass here to implement this method. Yes. You got the point? All the subclasses will be inheriting this method, and it is mandatory for all the subclasses to implement this method here. So the superclass is basically, it is making sure that all the subclasses, they implement this method here. They implement this method. That is the first point. So is it clear for you people? So what if the subclass is not implementing this method? For suppose, let's say the contract employee class is not implementing this method. Okay, it is not overriding it. Then it is an error. You see, this is actually an error. Yes. If the subclass is not implementing that method, then you got an error. What is the error? You see, the type contract employee must implement the inherited abstract method employee dot calculate salary, it says. So says that method is supposed to definitely implement. So the subclass is supposed to definitely implement that method. It says the subclass has to definitely implement that method here. So that is what it says. Yes. Yes. So that is the first point. So can I have yes or no? Is it clear for you people? Okay, good. So the second point is, by defining this method in the superclass, by defining this method in the superclass, we are making sure that all the subclasses, they override this method. When I say they override this method, we are making sure that all the subclasses will override this method, right? When I say the subclasses will override this method, that means they should follow the same signature, right? All the subclasses, they have to follow the same signature. That means, in other words, I can say that the way this method is defined in the subclasses is standardized. The way this method is implemented in the subclasses is standardized, because all the subclasses will follow the same method signature, right? Yes. So all the subclasses here will follow the same method signature. So that method is standardized now. Yes. Okay. So the way the method is implemented is standardized. That is the second point. So through the abstract methods, a superclass is making sure that all the subclasses will follow the same method signature and implement that method. Because they have to override all the subclasses to override this method, right? In overriding, they will follow the same method signature. So that is another important point here. Yes. So any questions in this regard? Okay. Now you see the class here, it is abstract, right? Only in the abstract class we can define abstract methods. Or in a class, how many abstract methods can we define? In a class, how many abstract methods can we define? So actually there is no such restriction. You can define any number of abstract methods. In a class, you can have any number of abstract methods. Okay, fine. Next, can we define non-abstract methods in this class? Can we define non-abstract methods? Non-abstract method means the method which is fully implemented. Non-abstract methods means which are not abstract, which are complete methods. Yes, you can do that. We can. You see, for example, I can define a method here, get details. Now this method, when it is invoked, let's say it will display that employee details. Let's say. So employee details. say ID, name, designation, phone, and so on. You see, I can do this. We can define both abstract and non-abstract methods in the class. Okay, so you can also make a note of it. So in the class, we can define both abstract and non-abstract methods. Okay. Yes. Next, you know, can we instantiate abstract classes? Can we instantiate an abstract class? Instantiation means creating an object. So can we create an object for the abstract class? Can say, what do you people think? Can we instantiate an abstract class? No. Yes, we can't do that. We cannot instantiate an abstract class. We can't do that. So why we can't do that? I'll show you people. You see, you cannot instantiate an abstract class. Employee, say new employee. If I do this, I'll get an error. So what is the error? It says cannot instantiate the type employee. Yes. Okay. But why can't we do this? What do you people think? Why can't we do this? Just a minute, please. Just a minute. Sorry. Okay. So I got answer since we have some abstract methods. Yes, you see, because in the abstract class we got abstract methods, right? Abstract method means, so basically it is an incomplete method. It is a incomplete method, I can say. So the method which is not complete. So I got several such incomplete methods, abstract methods, and it indicates that here the class also is abstract. That means a vague or incomplete class. The class is also an abstract class. It is an incomplete class. Okay. So if it is an incomplete class, an abstract class, you see, if we instantiate such class, you see the objects which are created for that class, they will not be fully functional. The objects of that class will not be fully functional here. The objects are not fully functional, right? So because that class is incomplete class, you can say an abstract class is definitely an incomplete class. That's the reason why you cannot instantiate that class here. Yes. Okay. So hope this is clear for you. Again, I got a question here. You see, if this class is incomplete, okay, if we cannot instantiate this class, if we cannot create objects for this class, then what is the purpose of this class here? So how do we use this class? What is the use of this class? A class which cannot be instantiated, if we cannot create objects for that class, how come we can use that class here? Yes, that's right. See, this class, it is purely, it is meant for the sake of inheritance here. So we can just use it for the sake of inheritance. So other classes will be able to inherit this class. They will be able to inherit the members of this class. They can make use of this class through inheritance. Okay, yes. This class can be inherited by other classes, right? So this is just used for the sake of inheritance here. Yes. Okay, fine. Though we cannot instantiate it, but still you see we got applications. We can inherit this class. Other classes can inherit this class. They can use the common methods or members which are defined in this class. Not only methods, it's not only variables, but even, sorry, not only methods, but even variables. Members means it includes both methods and variables, right? Yes. Okay, fine. So, how few people got it? So that method, that class, abstract class, is purely meant for inheritance purpose. So that common members, the common code can be shared across the subclasses. That common code, it can be shared across the subclasses, I can say. Fine. Now, based on your understanding, I got few questions here for you people. What are they? So the first question is, can we declare this class abstract class as final? Can we declare an abstract class as final? Can we declare abstract class as final? What do you people think? No? Okay. Why so? Because you see, just now, as I told you people, the main purpose of abstract class is to be inherited by other classes. Other classes, they should be able to inherit this abstract class. You see, if we declare this class as abstract, sorry, final, if I declare this class as final, that means other classes will not be able to inherit it, right? So will there be any use for this class? No. If the class, you see, you know that already the abstract class cannot be instantiated. We cannot create objects for this class. Now the second point is here, you see, if I declare it as final, that means you can't even inherit this class. Other classes will not be able to extend this class. So there won't be any use for this class. You see, the final and abstract, I can say that they both are contradicting. We can't use these two keywords together. You see what it says? The class employee can be either abstract or final, not both. Okay, fine. Next, what about abstract method? Can we declare abstract method as final? Can we declare an abstract method as final? Again, we cannot do that. An abstract method cannot be declared as final because the reason is same. The main purpose of abstract method is that the subclasses should be able to override this method. The abstract method here, the subclasses, they should be able to override this abstract method. Now, if I declare this method as final, if this method is declared as final, then the subclasses, will they be able to override this method? Subclasses, will they be able to override this method? I can say no. They will not be able to override this method here. Subclasses will not be able to override this method. So that is the issue. Yes. So hope you people got it. Again, final and abstract cannot be used together. So if I declare a method as final, then what happens? That method cannot be overridden. The method cannot be overridden. Yes. Okay, fine. So can I declare an abstract method as private? Can we declare an abstract method as private? No. Why we can't do this? Why abstract method cannot be declared as private? Because yes, you see, the main purpose of an abstract method is that the subclasses should be able to inherit this method and override it. The main purpose of an abstract method is that the subclasses should be able to inherit this method, abstract method, and they should be able to override it. See, that method, that abstract method is not implemented in the superclass. It is actually implemented in the subclass. If I declare it as private, then subclasses will not be able to inherit that method. There won't be any use for that method. So you can't do that. Okay, you cannot declare the abstract method as private. Okay, you see, if I declare the abstract method as private, we'll get this exception. So the abstract method calculates salary in type employee can only set a visibility modifier, one of public or protected access. So either it should be public or protected here. Yes. Okay. So based on this understanding, so let me show you people a question. Okay. You have to answer this question. So we'll go through one exercise here. Okay. First of all, before that, just check this question. Yes. What's the answer? Okay. So what about others? Okay, so let's see what the answer is. You see, we got a class called as sub. So in that class called as sub, okay, it extends another class called as super here. I'm sorry, it extends another class called as super. So which method placed at class 6 causes? I'm sorry. Yeah. Are we missing anything? I'm sorry. Just a minute. I guess I didn't show you the other part of the question. Sorry, guys. Sorry. Yes, you might be confused here, but there is super class here. I'm sorry. I didn't show you people the super class. Just check the super class as well. Now you tell me the answer. Okay, let me explain. You see, we got a class called as super, right? In that super class, we got this method get num. It doesn't take any parameter. Yes. And the return type of this method is floats. That's it. Now here, the subclass which extends that superclass, in that class, what methods or which method if added causes the compilation to fail. So can we add this method in the superclass? Sorry, in the subclass. If I add this method in the subclass, will it be overriding or overloading? First of all, we have to check that. The method signature, is it same or different in the subclass? If I add that method, the method signature, is it going to be same or different? It is going to be same, right? The method signature is same. So this is of course overriding, but there are certain rules for overriding, right? So the access modifier should be same. Okay, in this case it is same, or it can be subtype. Sorry, it can be least restricted. So the other rule is the return type. Either the return type should be same or subtype of superclass method return type. But here we got a totally different return type. We got a totally different return type. Yes. So this is not allowed. Superclass method is float. The subclass method is void. So you can't override it this way. It is not possible. So this first option A is the wrong answer. The second method, if we add it, it will be overloading because method signature is different, right? Third option is perfectly fine. There is no issue. Fourth option also D. You see, it is overloading itself, right? Yeah. So the answer is A. Okay. I'll show you people a question on the abstract methods. Just a minute. Mm, Sorry, just a minute. Mm, Research. Okay. So just check this question, all of you. Okay. So I got a couple of answers, I guess. Yeah. So let's evaluate it. So we'll check once. See, public abstract class test. Okay, there is a class which is abstract. So in that abstract class, we got two methods. One is method A and the other one is method B. We got two methods. Both the methods are declared as abstract. But for one method, there is no body, there is no definition. For the other method, we got a definition. So this is what you got here. So the question is, which two changes independently applied allow this code to compile? Yes. So the first option, add a method body to method A. So that method A is declared as abstract. So can we add method body to that abstract method? Can we do that? No, we can't do that, right? So the second option is replace lines 5 and 7 with semicolon. 5 to 7, replace it with semicolon. Yes, this works, right? If we replace it with semicolons, that means we are removing the method body from method B. Yes, we can do that. We can remove method body for B because that method is declared as abstract. So method is abstract, we cannot have method body. So that should be the correct answer. No problem. Next, B should be right. Next, C, remove abstract qualifier from the declaration of test. Remove the abstract qualifier from declaration of test. Can we do that? No. In the class, you got abstract methods. We cannot remove abstract keyword here. It is not possible. Okay. Remove abstract qualifier from declaration of a method A. Even we can't do that. So from declaration of method A, you cannot remove that abstract qualifier. Even that is not possible because for that method A there is no body, right? If there is no body, then it has to be declared as abstract itself. Yes. Okay. Next, remove the abstract qualifier from method B. Remove abstract qualifier from the declaration of method B. So can we do this? Is it possible? We can say yes, we can do that. So what is the right answer? B and E, right? So B and E are the right answers. Okay, good. So this is about the abstract class and abstract method. That's all. So if you people got any questions or issues in this regard, you can ask me. Okay, so if it is clear, I'll stop it here today. In the next class, I'll talk about interfaces and I'll give you people a case study on all the concepts which we have worked so far. Okay, I'm going to give you people a case study. It's going to be a little big, but you should be able to do that. Okay, yes, I'll help you out if you got any problems. So let's meet tomorrow and continue our discussion. Tomorrow I'm going to talk about interfaces. So all of you have a nice day.